we have very distinguished members on the panel this morning, and I think the topic is probably not different than what we've done in the past in the Open Daylight community, is to first draw the attention of the community to new areas that are emerging where maybe potentially we all have not spent enough time as a community, and then obviously encourage the community to have some ensuing following actions that are supposed to help us address the gap or decide if a specific use case is of interest for us as a community or is it not. So we have a pretty busy set of questions here, pretty busy agenda this morning. We have roughly 50 minutes or so from now. Would encourage you, I don't know if we have mic out in the audience. Can we have some mics out so people could also ask questions? Anyhow, it's not too large here, and if you have a question, we'll have roughly 5-6 different topics, so we'll go dedicate anywhere between 8 to 10 minutes per topic. If you have a question related to that topic, or at the end any other question that is related to this specific subject that has not been addressed before, feel free to chime in, raise your hand. We would like this to be as interactive as possible while the setting is a little bit intimidating. Don't take it too bad. So without further ado, what I'll do, I'll introduce the really distinguished panel members that we have this morning right now very briefly, and then the first question would be an opportunity for them to introduce themselves a little bit more in a more elaborated fashion while they are answering the question, so we save time and keep us all on agenda here. With alphabetic order, company names, Steve Nierenberg. Please raise your hand so the audience would recognize you. Jinzu Wang with China Mobile. Dave Ward actually at the last minute, as you guys know, global warming, for those of you who believe in that, he really has a fire close to his house. So we are really blessed with Jan Medved, who's one of the key contributors in Open Daylight from its insertion. Ariel Noy with HPE, working out of Context Stream originally and contributing to some of the interesting extensions of Open Daylight into wider network, as you will see. Chris Donnelly, who's also the TSC chair for OpenO, a MNO open source organization, and Chris Pin with Telstra. So as you could see, we were trying to get the makeup of the panel to represent both vendors as well as operators to make this as exciting, as enticing for you. And without further ado, I'd like to give each panel member an opportunity to introduce themselves while they are addressing that question of what are the lead use case for telco that they see are emerging, that they care about. What role would Open Daylight play in such evolution? And as you'll see, we'll also have a few slides for those who would like to use them. So maybe we start with you, Steve, and we simply go left to right.
Thank you very much, Uri. Can everybody hear me okay? Good. Oh, great. Thanks. As he said, my name is Steve Nierenberg. I work with for AT&T. I've been there for 36 years. As we've evolved from TDM to packet networking to multi-service delivery over networks. And You heard in the keynote this morning that Chris Rice gave some of the architecture and drivers behind how we're using open daylight, and our use cases are varied. We have the classic ones. When we think about software-defined networking, we approached it from a conventional connectivity perspective, layer 2, layer 3 types of services. And as Chris alluded to, with Open ROADM, we're doing layer 1 photonic wavelength management, but we also now can do cross-layer. We built a use case where we coordinate our backbone packet core with our optical network so that we can arrange bandwidth and links and MPLS tunnels across that whole architecture. So that's an example of a good cross-layer use case. Some other use cases, he mentioned application control functionality. We are also using for operations. You heard, I think, in the Neela's kickoff, how Fujitsu, I think, is doing some of the similar things using management. The nice thing about Open Daylight is a programmable environment, and then we've surrounded it with some of our own code, is it becomes sort of a network SDK. And it means that you can really build a whole raft of different scenarios against it and move and coordinate between the services, use service design, and really advance the state of network services. And that's really what we're trying to do with this controller architecture and with the broader open ecosystem overall.
Hi, I'm Chris Donnelly from Huawei, and as Uri mentioned, I'm the TSC chair for OpenO, which is an open source orchestration project. One of the use cases that we're following within OpenO and actively building towards is virtual CPE, and this is for both enterprise and residential users. And one of the things that we're trying to do with this use case is to allow for dynamic insertion of the applications, that we can put them in multiple different data centers, and then even potentially all the way at the customer edge, and then create connectivity services to stitch these together, and then of course service function chaining. So it gets to be fairly complicated when you get into it and get into the details. And it involves quite a number of different connections. You have to worry about the WAN, you have to worry about where you bring up the applications, and then how you connect together the different services, both the overlay and the underlay services. And this is where we need common orchestration services in order to be able to execute on the use case. Tying into Open Daylight, I think the real strength of ODL is in having common northbound and southbound interfaces that you can connect up in such an environment. It provides a great job of connecting across the WAN, and then the service function chaining and a lot of the support within the data center environment. One other thing I want to mention is I've been working on ODL even before coming to OpenO and coming to Huawei, and even from the pre-hydrogen days. And we were working at Cable Labs at my former employer on providing SDN control of the WAN. And so we built a packet cable multimedia plugin, and this was one of the things I thought was very interesting about ODL was the SAL, and being able to use additional protocols to connect to the devices that were already deployed in the network. So ODL is not just for greenfield opportunities, it's also for brownfield support for the billions of dollars of equipment that have already been deployed in carrier networks.
Crispin.
What a great place to hand over. Crispin Blackwell I'm responsible for the engineering team that builds out all of our global enterprise products at Telstra. Telstra is probably not necessarily familiar to most of you. We're a carrier based out of Australia, the incumbent carrier, and a full service carrier, so fixed, mobile and paid television. And I guess the kind of challenges we face, therefore, are a couple. Firstly, we're in a world, as any carrier is, where the amount of data going through our network is just growing astronomically. And in fact, if you look at the sort of numbers 10 years ago, we had about 10% of the carriage of our network was for data and about 90% for voice. And of course, that's now inverted. And the only difference is the voice numbers in terms of sheer volume is about the same. The data has just gone through the roof. And what you need to do to be able to support that is, of course, change your network fairly dramatically, change the economics of building that network, change the resilience of that network, because the expectations on the carrier have changed dramatically. So we look to how we can use a range of new technologies to help us achieve the outcomes, just in terms of sheer economics. At the moment, SDN and NFV capabilities, they're probably more expensive than traditional technologies. There'll be people who try and argue to me that it's cheaper today. But just in terms of delivering the expectations of what enterprises are trying to seek to get out of the network, the resilience, the speed, the self-healing, we need to be able to deliver this in next generation ways. And we also can't be tied as tightly as we probably have previously to the architecture. We need that open standards, and that's where we see partners and solutions like Open Daylight helping us get almost the future-proof capability, that flexibility to say yes, as we transform, we're not just doing it on our own, on a small island on the other side of the world.
Ariel.
Hi, I'm Uri Elzur. I'm from HPE, CSP ContextStream CTO. As ContextStream was bought by HPE a year ago, and ContextStream was focused about all the time for carrier space, how to enable them to have the SDN. So ContextStream was an SDN company. We did a few use cases of subscriber-aware satisfaction chaining, and we are continuing to trial that, an SDVPN. But coming to HP, then we were focused, we got another focus, which is the OpenStack networking, really to enable what you just described as to enable ubiquitous networking between multiple sites, to have the speed and feeds that you really need. So currently, the OpenStack performance is not there, and the complexity of the networking inside of it is kind of difficult. So we allow you to have the VNF distributed and federated between the different locations. So you will have the ability to have the mobile edge computings and the federation that you need, and the complexities that you need inside OpenStack between different OpenStack. I will explain that later in the next question.
So you have another slide here if you want to relate to that. I don't know if you wanted to talk to this or you want to talk to that later.
That's more suitable.
Sorry?
Those slides are better for the next question.
Perfect. We'll do that.
Okay.
Okay, Jinzu.
This is Jinzhou from China Mobile. Yeah, I'm the SDN team project leader and takes responsible for SDN and white box developing. And China Mobile is the largest mobile operator in China, and we provide the service to exceed 99% of people in China. And NFV and SDN is the most important technology for our next generation network evolution. And in fact, we have used Open Daylight 2 years ago. And we deploy Open Daylight in many scenarios, including data center, SDN-WAN, and also in SPTN. This slide shows one of our deployment example in our data center. So we can see in this slide that we integrate the OpenStack and the OpenDaylight in our network. And at the northbound, we use OpenDaylight to control OVS to provide a service for our cloud users, such as the layer 2 switching, layer 3 distributed routing, security group, and the ARP process, and so on. And on the other hand, we use the OpenDaylight to control the network function or virtual network function, including firewall or load balancer or VXLAN gateways, and to provide the whole package services to our cloud users. And the next slide, please. Thank you. Thanks to the open source SDN controller, we can make the multi-vendor deployment in our network. This is a very important feature, and it is a very desired requirement of our network. So we can see that in our deployment, we use OpenDaylight to integrate the Open vSwitch, and when there is router, when there is firewall, and when there is load balances as a whole total solution in our network. And so this deployment, so we use OpenDaylight to take charge of the routing related tasks, and we use the network function solutions to integrate in our whole total solution. We have implemented these solutions and also make trial in our networks, and we plan to make the commercial deploy at next year. Besides the database deploy scenarios, we also make the SDN applied in the PDN network. We have initiated a project in the OpenDaylight named the SPDN project, aims at involving PDN network towards the SDN. We plan to develop the the domain controller in SPDN based on OpenDaylight. Yeah, that is some brief introduction about the China Mobile usage. Yeah.
My name is Jan Medved, and I'm in Cisco Systems in the Chief Technical Officer and Architect organization, and I've been actually involved in OpenDaylight since day one. I'm probably one of the guys who started it, and I'm leading still the OpenDaylight team at Cisco that is contributing to open source and also doing projects, internal projects at Cisco. We're doing also other technologies and other projects like segment routing or participate in routing projects and routing software in Cisco products. So when we designed and architected OpenDaylight, it was first and foremost architected as an application development platform where one of the applications actually happened to be an SDN controller. And as the other panelists have attested, this truly kind of proved to be the case. I mean, there's a variety of applications that are branching out of the kind of SDN controller realm. And you can put all kinds of applications on OpenDaylight. Networking is one example. The other interesting area where you actually start seeing OpenDaylight being used is IoT. Nila mentioned an IoT use case in his keynote today. We are also, you will see the OpenDaylight technology actually being embedded in some of the IoT products and solutions coming out of Cisco. As an application development platform, it will also be embedded in some of the products and solutions coming from like route distribution and kind of, if you will, XR augmentation, iOS XR augmentation, or helpers to orchestration solutions for cable industry, things like that. Not necessarily, well, not here that it's based on OpenDaylight, but OpenDaylight will be deeply embedded in some of the products coming out of Cisco.
Okay, so that was the first round, and obviously people took a little bit more than the 2 minutes I allocated to them, but we'll see how we deal with it. Maybe the next question, not everybody is going to reply to, or we'll keep you guys a little bit excited and waiting for the next panel on this subject. But I want to build on what Jan just mentioned about OpenDaylight being an open platform. And one observation, and I'm trying to put it on the board right now with a little bit simple diagrams. I'll show you two concrete examples and then ask the panel members to relate to it, is Jan just mentioned ODL as an open platform, and the kind of interaction we see in the industry is where, to some simplistic-minded people like me, I was expecting the model on the left where a cloud management entity like OpenStack is going to manage something like an SDN controller, like other controllers, where SDN is an extension of somewhat limited, not as feature-rich, maybe potentially not as scalable network features, technologies available with a cloud management infrastructure. However, we do see situations, and that was also evident in Jen Zhu's example just a few minutes ago, where ODL is playing a larger role, maybe even such that it is some sort of an application manager. Here is an example out of AT&T's eComp. That's a white paper that is publicly available, and you could see the stack of controllers that are sitting there in the middle, and maybe all of them, some of them are directly interacting with virtual machines. I'm sure we'll get some comments from Steve about that. Here's another example, and in that example, you actually have different regions of the end-to-end solution. And without, because I don't want to speak too much, I actually prefer the panel members to use most of the time, and you guys, please chime in. On the right side, we actually have two types of SDN controller interaction. There is what's called the data center SDN controller, which is really the model I had on the left, where you have an open daylight specifically as with a plugin into Neutron. But there is another entity here, while this diagram doesn't show it clearly enough, where the main orchestration, the NFVO specifically, is directly dealing with open daylight. But then you have other incarnations of open daylight where it is actually directly interacting with call them VNFs, virtual network functions, like what you see in the access layer on the left. So going back to the question here, what you guys think is the model? Are we going to see all of those models coexisting? What are your thoughts? And maybe I'll start next time from the other side, but because the two examples here are related to Steve's work and to Chris, maybe you guys want to kick it off.
Thank you very much, Uri. Yeah, so I guess we would kind of fall a little bit in the second and third model. One of the things to think about is that controllers really need to be able to work with multiple orchestration and runtime environments. And so OpenStack is certainly a major component of how we execute, but not all environments can be OpenStack based. You know, public clouds or private clouds that are set up using particular software, you know, whether it's from one of the big web scale cloud companies, those environments need a similar level of control and orchestration. Then when you get into smaller things like virtualized appliances that you might use in a customer prem, where you want to be able to organize a series of network functions and deliver them as micro appliances, again, that type of environment. So that kind of is like the third model, where the controller controls the runtime. Then flip it the other way is you're not only controlling your orchestration, but the orchestration is interacting with your control and providing either network service control, infrastructure control, or service control type functions. So, you know, you have both dynamics in play. And that's, you know, one of the ways we're trying to use it to create a more sophisticated way of stitching together infrastructure, network service, and end user services in a chain.
Thank you.
So as Uri mentioned, within OpenO, we have 4 different roles for the SDN controller, 4 different deployment scenarios. And what we found is if you try to just bring up SDN control under OpenStack, it's pretty limited if you're using the Neutron plugin. It doesn't do a very good job with layer 3 networks, with the WAN, and it has some limitations with SFC as well. So we need to have other deployment roles in addition to that one. What we're working on within OpenO is we have different components. The NFVO component uses OpenStack and then connects down to ODL or ONOS for the data center. But the SDNO component can set up the connectivity services. And in that case, the SDN controller is next to OpenStack instead of underneath it. And this will allow us to do a better job controlling the WAN connections, whether whatever the protocol is and whatever the controller is. We also have the concept of a supercontroller, where we can have one controller controlling other controllers. We don't quite go down to OpenStack in that model, but it works within the SDN domain. And then we also have the SDN controller doing the SFC in the data center, while you have OpenStack and Neutron setting up the basic connectivity for the data center. I don't think that there is a one way to do it with the current technology and with the current OpenStack. And so depending on the operator network and the flexibility that's required, at least in our case, 2 of the models are required.
Maybe we go next to Uriel, because I thought you wanted to use one of your slides here.
Yeah, so you can put my slide. Just to your addition question is that we see that actually all combination happening. For example, last year we presented how Open Daylight can boost the EPC, the PGW, and the SGWs by separating them between controller data plane and the Open Daylight configure the open flow switch to do the data path. So really that's a combination for another angle. Just Open Daylight even boosts the VNF. And over here what we are demonstrating is Open Daylight communicate, if you just do the previous one, Open Daylight communicate with the OpenStack and actually being the Neutron plugin and boosting the performance of OpenStack. So we allow you the ubiquitous networking between all locations and having the federation between those locations. The performance is 100x, okay? It's the fact that you saw problems in the performance that you just mentioned, especially in layer 3, because you just use, maybe you just use OVS DPDK and not using OVS DPDK plus ODL, okay? Once ODL gets into the pictures, layer 3 happening in the OVS DPDK, okay? And in the OpenFlow rules, and we have a demonstration that's showing 100x performance on that. The drawbacks of OVS DPDK is the manageability and the visibility into the OpenStacks. But then we introduced the Open Daylight, and we put features like tap capabilities, like monitoring of the ports and the links and the underlay links, and that enables you to have a really VXLAN tunnels between multiple sites and have them all ubiquitous networkings on that. If you can, and everything is based on Open Daylights. It's in Boron, and the addition is in Carbon that we're contributing. We actually won last night the Dragon's Den with that application, and I have later on you can jump to the booth and see a demo, and also in the demo theater. Over here, what we just shows that you can have multiple OpenStack, each one communicate with its own ODL clusters and have its own networking, but you can also have an ODL federation manager on top that's saying like the orange network and the orange network in two different VIMs are the same orange network, and then automatically they are connected, united together, and VXLAN from host to host directly, without external layer 2 gateway, double NAT, and all the other complexity that you are just mentioned. So if you have a direct host to host VXLAN, then you have a direct layer 2 and layer 3 performance with a wire speed with OVS TPDK and the open data.
So maybe one of the other operators want to relate to this from requirement point of view.
Okay, would you please go to the slides
Sure.
I just introduced? Yeah. The previous.
The previous.
Okay. So we can see this in slides that so the relation between the open daylight and OpenStack. So we have two kind of deployment. The first deployment is the on top is OpenStack, and the open daylight deployed under the OpenStack just as the common use. So we can see that ODL below the OpenStack, and we provide layer 2 plugin and layer 3 service plugins to the neutral to provide the virtual network services. And another kind of deployment is, we can see in the picture, is our CMCC SDN MPP. In fact, in this deployment, the SDN MPP implement a bunch of functions. We can see it as the application layer controllers. So the function of the SDN MPP consists of two aspects. So one function, the one is that it provides the unique virtual network view and the configurations. Another function is that the SDN application controller provides the SFC functions. So we use the SDN APPs as our application controllers to provide the unique network access portal to our users. So on the one hand, so our SDN APP invoke the neutral API to implement the network functions such as creating virtual network or creating VM or attach VM to the virtual networks. And on the other hand, our application SDN APP provides the SFC functions to our users. So as for our users, they can through the SDN APP to organize and orchestrate their service function flows. And this SDN APPs invoke our ODL SDN controller under the OpenStack to implement the SFC functions. This deployment have already implemented in our network, and we are now making trial in our data center now. Yeah. Okay.
Jan, Christine, or next one. So you want to make some comments, Jan?
No, not on this.
Okay.
Just,
So obviously the question of the APIs is also related.
can you put on your previous slide? I have some comments on this. I mean, your slide with the OpenStack and Open Daylight.
Oh, that one.
Go back. Yeah, this one.
Yes.
So I'll be a little contrarian here, and
We need that, so feel free.
so we networking people, we tend to think in layers. And OSI, like 7 layers, everything. Something has to be on top of everything else, and there's APIs in between and all that stuff. 25 years ago, being a grad student in University of Toronto, there used to be this joke: how would a networking person build a horse? And the way how a networking person would build a horse is put down 4 hooves and wire them, then build the legs, wire them. And finally put the body and put some wiring in the body, and then build the head and put some orchestration in the head. So very nice layered, modeled view of the world, and that's how we tend to think in networking. Now, is that really in the era of web scale? Is that really the right way of doing things? And I would say that rather than kind of going in layers and trying to have kind of OpenStack on the top and then Open Daylight on the bottom, or controllers of controllers, or whatever, kind of everything nicely layered. Rather than doing that, what actually the world is going to is microservices. So you've got the horizontal scaling of things. You've got things like Kafka, you've got things like Dockers, and they all need to be put together. And rather than having big monolithic systems that talk horizontally. You've got small systems and small pieces of functionality that are connected horizontally with well-defined APIs and well-defined services that they provide to each other. That way you get the reuse. That way you get the scale. You can scale things with smaller units of functionality. You can just fire up a lot of them, all the Amazons and the Googles and the Netflixes have proven how to do this, and we as the designers of the next generation of orchestration systems, we have something to learn from them. Now, how does this apply to Open Daylight? It actually turns out Open Daylight is very well suited for this architecture. I mean, we started with the layering as well, being networking people and coming from the building a new horse, everything was layered. But as we evolved the architecture, we actually realized the MD cell is a bus, and the components are like microservices being on that bus. And there is no difference between whether you've got plugins for controllers, and there is no difference whether it's application plugins. All applications, all microservices, they do their own things. So it is actually very well suited to the microservice architecture. And now going forward, how can it help? Because everybody's building microservices kind of with Dockers and Docker containers and putting them around Kafka buses and putting them in NoSQL databases. Again, it turns out that Open Daylight has something to do and something to say even to these people. And the secret sauce here is Yang modeling language. Because once you start doing these microservices, the important thing is so that these services can talk a common language and can talk common schemas. And it turns out, again, like by either lucky choice or foresight, we chose a modeling language and common kind of language that all these components that can be put together as on an application platform can talk to. And you can easily make them interoperate with each other and start doing their use. So really kind of going forward, I would rather say, rather than having, big systems and having the trouble characterizing what is orchestration, what is controller, what is actually, something else. We have actually Open Daylight running now in the agent, in the devices as the honeycomb agent, right? So, I mean, the boundary gets completely blurred. It's all microservices, all talking some kind of a common language, some kind of a common schema, and that's where the world is going.
So I think instead of contrarian, you may come out as a futurarian with a future probably panel that we should have next time is to talk about the way we think containers, microservices, controllers like
Exactly. So, for example, you can, rather than having a big monolithic Open Daylight, you can actually have smaller Open Daylight instances running in Docker containers and maybe put them together over a Kafka bus, maybe actually use the Open Daylight messaging itself to implement a smaller bus. Again, you can use an external NoSQL database like Cassandra or Mongo or whatever to store data. Or, the work that we've been doing is make actually OpenAI data store being a kind of database that can serve other service-oriented Open Daylight instances. So that may be the evolution where we want to take the architecture.
So I think we have few elements here that are at play, and like a normal panel discussion, we are not here to resolve everything. We are really, first of all, trying to bring to the surface all the interesting conversations that are happening in the background to enrich what we are doing as a community. I think so far we heard APIs, we heard microservices and potentially macro orchestrators, but versus layered type of an architecture. But we also want to make some progress with the telco specific aspects. And so let me actually, with that thought in mind and some of pictures stolen with pride from your friendly Google environment. SD-WAN is also making lots of noise these days. Many people are excited about that. You could read any article you want these days about SDN technology hitting the wider network. cloudification of the wider network. To some people, that represents really combination of, and I think, Steve, you related to this earlier about layer 1 and layer 2 and layer 3, bringing them together. To other people, that relates to the concept that maybe what I'm going to have close to the edge for many reasons, some sort of a compute entity to serve the emerging needs of severely more constrained real-time responsiveness, like what some of the architects of 5G would like to see. To some people, and that was mentioned here as well, IoT may be driving that. So like always, you will find multiple communities that are trying to address that, and we are somewhere on the curve of hype when it comes to this. SDN probably has its roots in the separation of data and control, probably with NFV, started a little bit closer with the more contained environment of a data center under OpenStack, as an example, vSwitches, accelerated data planes. But now we are potentially on the brink of a new era. So who wants to take that question first?
If you don't mind, I'll take a stab at this. So one of the interesting things, and this is where I'll say the technologies of SDN and NFV and what users are trying to do kind of come together in a nice way. Classic networking was the network is a transport vehicle, and the most amount of application awareness you had was, a EXP bit or a diffs or a code point, and you basically said, give it higher priority or give it low priority or whatever. But when you have something like SD-WAN where you have multiple paths of connectivity, and you can combine that with application awareness, and this is really where it's important that the application networking considerations and the network transport and policy-based networking really come together. So this is why one of the things that we have to come up with is new ways of carrying application traffic, because most application traffic these days is being encrypted, which means you cannot do your normal simple DPI and say, oh, okay, I recognize that this is an image transmission, or this is this application that needs these characteristics. So there really needs to be sort of a new fusion between application and networking. So SD-WAN is kind of a first step in that, in saying, all right, I have multiple paths and I can use QoS-based policy decisions on which path to use. But really, it's a toe step in application-aware networking and policy-based networking, and using SDN and NFV techniques to instantiate that, which you couldn't really do flexibly before because of embedded proprietary network elements that didn't give you the flexibility to do dynamic control.
Anyone else? Ariel?
Yeah, so we see evolution of SD-WAN. So it started with just a better uplink, okay? Just a better control of my uplinks. And then over there, most of it is like, at the end of the day, sorry guys, it's like the over-the-top will take the space, okay? Because they can combine multiple uplinks from multiple service providers. But for the carrier, they have the opportunities. And that's what we're trying to show over here. And we have later today a demonstration for that and a session on that. We are part of the Uni Manager project, is the ability to enable what you just described, the mobile edge computing, the branch to branch directly and the branch to your telco cloud or your local cloud. And we see that as a network of clouds. So today it's not just I have a cloud, I have clouds of clouds, which they are all around available for my enterprise, and I want as more as I have technologies into the edge, then I have more application, and I need them closely and I need them dynamically. And what we are demonstrating is with the ubiquitous networking that we have is the ability to connect the branch directly to the cloud without any additional layers. It's like you get to my branch into my into my tenant network inside the OpenStack, which is local to the edge, and then connecting between different OpenStacks in different edge computings. And then all of that, I have my clouds of clouds, which are resources dynamically allocated to me.
Anyone
So-
else? Crispy?
Well, I'd probably take an even simpler view. So just pair it right back to why does it matter to a customer? It matters to a customer because SD-WAN's the first thing that's been driving zero-touch provisioning. So you can actually get it fast. So if you've got a capability to say, get me my network and get me the capabilities in that network, and then give me, the customer, control of the network. And SD-WAN's the first sort of pilots to deliver that. But the service provider is changing and adapting. The challenge in all of this, and it gets back to the innovator's dilemma, how much of your traditional business do you cannibalise to grow the new business, and how much of your MPLS traffic can you risk moving into an SD-WAN world, particularly if you look to merge the capabilities and say, yes, I've got customers who want to extend their MPLS network. They want the ability and the speed of an SD-WAN capability. Please merge the two capabilities so that I've got one network. That's what they want. Of course they want that. And the operator's going to sit there and say, well, look, how do I retain the greatest value while creating the greatest opportunity? And that's the challenge we're in. The technology is there to do it, and it lines up with all of the different segments. It's not required to do 5G, but there are ways we can achieve more doing this kind of solution.
Great.
Yes, I think zero-touch provisioning for the customer and being able to deploy new services quickly is important. I think also being able to dynamically place applications, place VNFs for the customer in a more flexible manner for the provider, where there's space. Whether it's close to the customer or up in a data center, or for latency and sensitive applications, it could be like an Amazon Web Services. It could be somewhere far remote. And to Jan's point, it could be a container that runs on the CPE device that's in the customer network. But this requires a lot of control, a lot of programmability. So we need something like SD-WAN to do it. And we also have to be careful with the choice of protocols. The average customer today, I'm talking residential, uses about 33,000 connections per day, so about 66,000 flows. And typically there are only a couple of paths through the network. So you don't want to have a lot of flow state per customer, especially if you're talking about millions of customers, for maybe two paths. So we need to use netconf, use things like PCMM, use other tools to be able to essentially program these flows, but not in bundles instead of on a connection by connection basis.
Okay, so from the point of view of China Mobile, we can say that we indeed get more benefit from the SD-WAN because SD-WAN's flexibility and its automations. One of the example in our deployment is we deploy SD-WAN in the VPN network scenarios. So we make SD-WAN VPN scenarios application to fast our service opening times. Before we deploy SDN, we also need maybe 1 day or 2 days to open a new service to our customers. But after deploy the SD-WAN solutions, we can start our service in few minutes. So this is a very great benefit to our operator network. And another use case is that we apply the SDN controller in our to control our call router to load balance the network utilizations. So we can load our capex in our networks and improve our link utilizations. This makes our service more valuable and more competitive. Yeah.
So we technically have just a few more minutes, and there's been other conversations I wanted to have here, but obviously the time is not going to be permitting to do that. I don't know if somebody else needs to use that theater later. anyhow, to stay within the bounds of the time we've allocated, I'd like to see if there are any questions on the floor that somebody would like to present. Not surprised to see that firsthand specifically. Dan?
Sort of simplified partition of the telco network is what's out in the network and then what's in the data center. And more function and control is moving into the telco data center. Where do you think open daylight will have its greatest impact soonest? In the out in the network parts or in the data center parts?
Look, I'll have a crack at it. I think, when you think about where you have to change the network in order to, my point before about the amount of bandwidth growing in the networks, we're probably going to transform more of the outer network in the next 3 years than we're probably going to change in the data centers, which we've done in the last 3 years. So from my point of view, I think actually open daylight probably has more opportunity in the outer network as we build that out.
Yeah, one of the things...
I would be contrarian again, and I actually say it's both at the same time. And just given the use cases that are out there that mentioned even today in Neil's keynote, I mean, you've got Alibaba on one hand, which is data center, you've got AT&T on the other hand, which is the WAN. So you can kind of see it taking off in both areas.
Yeah, to reinforce that, the one nice thing Open Daylight brought was brownfield adapters. So we've been able to use it to control legacy elements and orchestrate them as part of a holistic structure with eComp and other components. And this is how we did network on demand, this is how we did NetBond. And as we introduce new services that were prem-based and introduce capabilities that are data center-based. So it's really across the board, and that's one of the nice things about the architecture. It's so flexible.
Yeah, that's the beauty of Open Daylight. It's open source. Everybody contribute. Every company focus a little bit different, and we all come up with the same releases. Every service provider has his own agenda and priority and history, and every other player has its own target. So it will be in parallel.
Any other questions from the floor?
Are you over there?
Yeah, sure.
Very simple. So actually, you try to solve a lot of problems. This problem, we try to solve it before SDN concept. Okay. Except you added a lot of automation intelligence into this concept of SDN control. So my question is, what is the difference between SDN controller and advanced SMG system?
Okay, you want to take it? Just repeat the question.
We have some experience about this question.
So just repeat the question for the audience, because I don't know if everybody was
okay.
able to hear.
Okay, so the difference between the SDN controller or SMP in our deployment is that we use SDN controller to control the OVS to provide the cloud networking services. So the protocol we use is OSDB and OpenFlow. This wide protocol can set an OpenFlow entries to the OVS, and it is fundamentally different from the SMP because SMP mainly focuses on the configuration, not the network service implemented. Yeah.
I don't know if we want to let you jump in the middle. The contrarian has to be at the end always.
No, I would just like to add, when you mean SNMP, I mean it's a management system. And I would kind of rephrase the question maybe a little bit, or say that the next generation management system is going to be built around a microservice architecture, build and model-driven systems. And as proven, again, by using example from today's Neil's address, the Fujitsu architecture, next-gen architecture of a management system is built exactly like that.
So my history, I built two companies. One, Sheer Networks, bought by Cisco. It's doing network management, and today it's part of the Cisco network management. My second startup is CounterStream, bought by HP. It's an SDN controller. Some look at it as as the same, okay? Starting to do network management, flow through provisioning and monitoring and for root cause analysis in the controller layer. I personally think that the whole movement of the industry into control is actually having the controller and controlling the network. That yes, you need a network management. Open Daylight is a good platform to do also network management by its own platform, okay? But you really want the control to be in the controller and not just configuring previous protocol and using the same mechanism, is really to enable you to open up new ways of looking at the network, enable you to open up new application and not just go back to the old previous configuration. So if you just have old previous configuration, you just leverage the fact that you build all together, all of us build together a better network management.
But the boundaries between the network management system and the controller are blurring actually.
Yeah,
And again, it's going to a set of microservices that are executing somewhere in the cloud.
So just a time check. Some people may need to go to the next session, which starts in a couple of minutes. Happy to keep us going here. If the audience is interested, I think some of the panel members also need to excuse themselves as we are running a little bit over time. So first I want to have a formal closure here. As you could see, we were very careful and they chose sitting kind of a boy-girl, so that we don't have operators clashing or vendors clashing here. But I think it was a good opportunity to have a dialogue here that I think we need to potentially have a little bit more of because we are getting out of the initial phase of, oh, let us just show you that we could do something in that, using that notion of centralizing some aspects, working with cloud management. We are now getting into completely new opportunities and new eras. And thank you, guys, for highlighting some of those. I think you reserve the seat on the next panel as well. We need a contrarian that always makes the interaction a little bit more exciting. So first of all, I want to have a round of applause to the panel members. Don't take it too bad. So without further ado, what I'll do, I'll introduce the really distinguished panel members that we have this morning right now very briefly, and then the first question would be an opportunity for them to introduce themselves a little bit more in a more elaborated fashion while they are answering the question, so we save time and keep us all on agenda here. With alphabetic order, company names, Steve Nierenberg, please raise your hand so the audience would recognize you. Jinzu Wang with China Mobile. Dave Ward actually at the last minute, as you guys know, global warming, for those of you who believe in that, he really has a fire close to his house. So we are really blessed with Jan Medved, who's one of the key contributors in Open Daylight from its inception. Ariel Noy with HPE, working out of Context Stream originally and contributing to some of the interesting extensions of Open Daylight into wider network, as you will see. Chris Donnelly, who's also the TSC chair for OpenO, a Mano open source organization, and Chris Pin with Telstra. So as you could see, we were trying to get the makeup of the panel to represent both vendors as well as operators to make this as exciting, as enticing. We have very distinguished members on the panel this morning, and I think the topic is probably not different than what we've done in the past in the Open Daylight community, is to first draw the attention of the community to new areas that are emerging where maybe potentially we all have not spent enough time as a community, and then obviously encourage the community to have some ensuing following actions that are supposed to help us address the gap or decide if a specific use case is of interest for us as a community or is it not. So we have a pretty busy set of questions here, pretty busy agenda this morning. We have roughly 50 minutes or so from now. Would encourage you, I don't know if we have mic out in the audience. Can we have some mics out so people could also ask questions? Anyhow, it's not too large here, and if you have a question, we'll have roughly 5-6 different topics, so we'll go dedicate anywhere between 8 to 10 minutes per topic. If you have a question related to that topic, or at the end any other question that is related to this specific subject that has not been addressed before, feel free to chime in, raise your hand. We would like this to be as interactive as possible while the setting is a little bit intimate.
MPLS tunnels across that whole architecture. So that's an example of a good cross-layer use case. Some other use cases, he mentioned application control functionality. We are also using for operations. You heard, I think in the Neela's kickoff, how Fujitsu, I think, is doing some of the similar thing using management. The nice thing about Open Daylight is a programmable environment, and then we've surrounded it with some of our own code, is it becomes sort of a network SDK. And it means that you can really build a whole raft of different scenarios against it, and move and coordinate between the services, use service design, and really advance the state of network services. And that's really what we're trying to do with this controller architecture and with the broader open ecosystem overall.
Hi, I'm Chris Donnelly from Huawei, and as Uri mentioned, I'm the TSC chair for OpenO, which is an open source orchestration project. One of the use cases that we're following within OpenO and actively building towards is virtual CPE, and this is for both enterprise and residential users. And one of the things that we're trying to do with this use case is to allow for dynamic insertion of the applications, so that we can put them in multiple different data centers, and then even potentially all the way at the customer edge, and then create connectivity services to stitch these together, and then of course service function chaining.
For you. And without further ado, I'd like to give each panel member an opportunity to introduce themselves while they are addressing that question of what are the lead use case for telco that they see are emerging, that they care about. What role would Open Daylight play in such evolution? And as you'll see, we'll also have a few slides for those who would like to use them. So maybe we start with you, Steve, and we simply go left to right.
Thank you very much, Uri. Can everybody hear me okay? Good. Oh, great. Thanks. As he said, my name is Steve Nurnberg. I work with for AT&T. I've been there for 36 years. As we've evolved from TDM to packet networking to multi-service delivery over networks. And you heard in the keynote this morning that Chris Rice gave some of the architecture and drivers behind how we're using Open Daylight, and our use cases are varied. We have the classic ones. When we think about software-defined networking, we approached it from a conventional connectivity perspective, layer 2, layer 3 types of services. And as Chris alluded to with Open ROADM, we're doing layer 1 photonic wavelength management, but we also now can do cross-layer. We built a use case where we coordinate our backbone packet core with our optical network so that we can arrange bandwidth and links. And
so it gets to be fairly complicated when you get into it and get into the details. And it involves quite a number of different connections. You have to worry about the WAN. You have to worry about where you bring up the applications, and then how you connect together the different services, both the overlay and the underlay services. And this is where we need common orchestration services in order to be able to execute on the use case. Tying into Open Daylight, I think the real strength of ODL is in having common northbound and southbound interfaces that you can connect up in such an environment. It provides a great job of connecting across the WAN, and then the service function chaining and a lot of the support within the data center environment. One other thing I want to mention is I've been working on ODL even before coming to OpenO and coming to Huawei, and even from the pre-hydrogen days. And we were working at Cable Labs, at my former employer, on providing SDN control of the WAN. And so we built a packet cable multimedia plugin, this was one of the things I thought was very interesting about ODL was the SAL, and being able to use additional protocols to connect to the devices that were already deployed in the network. So ODL is not just for greenfield opportunities, it's